My name is Ahmed Abou-Alfotouh. I'm a senior fellow at AMD, and my colleague here, Song Kok-Hong, also senior director from AMD today. We're going to talk about the OI sub-project overview, what have been done over the 2023 contribution, and also give update about the high-speed workstream system, high-speed and system workstream update. History-wise about OI, it was formed in March 2019. The concept started before that, but officially was formed in March 2019 under the OCP server program. And the goal of the OI is to build the infrastructure for fast adapting upcoming products for AI and HPC application. And you see over the last 5-6 years how the adaptation was moving very, 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 very fast. And with the community contribution, we made huge progress, and you see the timeline and how we advanced from, I would say, nothing to where we are today. This year contribution, we have the OM 2.0, we have the UBB 2.0, and the expansion card 2.0. It has been, all of these three have been released. We have 5 work streams. If you are not participating in them, consider participating in all of these 5 work streams. We have the high speed, and we have system, we have power, cooling, and OM tool. As I mentioned, over the last 5 years, a lot of things have been done. 2018 started with a concept from Meta about, okay, how we can put more cards and more dense accelerators into one board, one base board, and put more accelerators per rack. Over the last 5 years, a lot of things get improved. From 25 gig NRZ today, 112 gig PAM4. PCIe Gen 3 to PCIe Gen 5 and 6. 450 watt to 1 kilowatt. Air-cooled to air-cooled and liquid-cooled. And that was community contribution. We came together. We put all of this improvement over the last 5 years. The improvement in the density in the rack happens over the last 5 years of all of your contributions. Members in growing every year. Started with single company 2018, and now across the whole globe, contribution from companies globally. All of this contribution over the last 5 years wouldn't be possible without contribution from all of these members. Before talking about the build-up, you see these are the 3 main contributions. The OM 2.0, that the spec released in March of this year. UBB 2.0, also the spec released in March 2013, this year. This month, the expansion card, which is a new member to the family. We have been improving OM year after year. We have been improving UBB year after year. Expansion card is a new member to the family this year. I'm going to hand it to Song to talk about the build-up and the system, also the system workstream update.
Thanks, Ahmed. So this is the OAI system building blocks, right? As you can see that we have 8 OEMs sitting on the UBB baseboard, and we are actually adding a what we call expansion module for the 2.0. Comparing to the 1.0 and 2.0, 1.0 is more on the base focus on the OEM plus the UBB with a few SerDes for the scale up. But for the 2.0, we are actually putting more scale up capability coming up from the OS system. So going back to the 2.0 specification, I think we have presented to the audience quite a few times, and right now we are actually rolling the revision to 2.0 version 1.0, 2.0 and version 1.0, and the dimension is going to be the same, like 170 by 102. And 2 mandatory power input, the 54 volt, 3.3 volt for the board management, etc., right? And we also have the optional input voltage for 12 volt. that it also can be used for some of the VR or some of the low power component management as well. The TDP is going to be support up to 1 kilowatt, and it can power through the dual power entry. We're actually adding a additional power entry on the other connector. Comparing to 1.0, we only have one power entry, but in order to support a higher TDP of the OEM, we added two power entries so that they create the flexibility of the design of the OEM. Either you want to take into one power or versus two power entry. And in the 2.0, we also adding a 8 mm stack height connector. The original one is 5 mm and it runs pretty well. But in order to support the 1 kilowatt, we want to add the flexibility on the OEM design, and so that you can have a taller component of the bottom of the OEM. So, but there are some pros and cons, right, in terms of the SI, power delivery. These are something that when depends on the use case or the design constraint, these are the choice that you can have on the OEM side. But the whole goal is that even you have a 5 or 8 mm stacking height, the baseboard design, the connector stay the same. The only difference is that the OEM height. Okay. The SerDes speed is also pushing to the 112 gig PAM4, and the Workstreams also have done a lot of study. And because we're adding the new family, the expansion module into the design, we actually did a lot of assessment from our Workstream member, and from the OEM to OEM interconnect and OEM to the expansion module interconnect as well. And we do have some demo in the experience center that run by Broadcom and Amphenol, right? You guys can take a look at that and asking the question if you have, right? They also showcase some of the mechanical mockup as well, the expansion module, so that you can have a better idea on how the whole thing looks like. Okay. So UBB 2.0, comparing to the 1.0, we actually extend the depth of the PCB in order to support the longer OEM and also the expansion module as well. So as you can see that this is quite packed, quite dense design. We have the OEM, we have the expansion module, and we also have the PCI retimer, and also a lot more components like if any of the implementation require FPGA, require different kind of the power delivery. We do look into the overall form factor, right? It should be able to support all kinds of different applications that we want to implement. At the same time, that we also support the root of trust security module, and it's kind of getting more like what I call more mandatory requirement, right? If you have a FPGA, if you have a PCI switches, retimer, right? All need to go to the root of trust security module. And as I mentioned before, the end-to-end loss budget, right, the 28 gigahertz. Right now, we have some guidance in the latest spec that we just contributed last month and should be ready by following weeks or so. And we actually look at the two different loss budget from the OEM to OEM in terms of the definition where from the ball to ball or from die to ball, etc. Right? We have some detailed information in the specification. So the expansion module is 160 by 148. If you look at this one, it's almost look like a half LAN PCIe card, right? So the main application for this expansion module is for the scale out application. You can scale out to the retimer, or you can scale out with the different kind of implementation, right? You can have the purpose-built switches, or you can have some other thing that can fit onto this expansion module. Yeah, and it supports 2 power input, right? The main power is going to be 4854 volt, and 3.3 volt is mostly for the management low power devices. And TDP can cover up to 400 watts. For the retimer use case, we don't see that needed to 400 watt, Probably anything less than 200 watts should be good enough. But we do want to reserve more power later on if you want to have a purpose-built switches on this platform. And from the OEM side to the UBB, we do have a 2 high-speed connector that support the 112 gig. And we can support total up to the 8 by 8 lanes, 30 port. And for the scale up, we do see that for the 4 OSFP that we have been defined into the assessment and also into the spec as well to come out with the 148 by 160 form factor. And we also contribute, I think the Workstream also contribute the what we call the ejector, how you're going to park in the car, how you're going to eject the car. And I would like to thanks to H3C for the contribution to this mechanical ejector. And as I mentioned before, this design is not only target for real-time application. So it depends on the future use case of this expansion module, right? It can be a switch, or it can be a NIC, or it can also be an expansion memory as well. And if moving on, because of the AI evolution is so fast, there will be more implementation right outside of the OEM UBB that the end user can come up with their own design as well. Okay, and this is the overview and update from the OAI workstream. And thank you all for your time. And please get to the OCP server project or the OAI sub project and try to follow on and then come and join our community there. Okay. And now I'm open for discussion.
Anyone have any questions or comments?
Hello, thanks for the presentation. Do you have any comments on how you link that 5 or 8 millimeter that you mentioned about the stack height, connector height, with 1 kilowatt being increased power? So is this something to do with how you place the IBC and the second stage in that 5 to 8 millimeter space?
I'm sorry, can you repeat the last part?
So you mentioned that you have increased that connector height from 5
to 8.
Between 5 and 8, I believe, are two options.
We have 2 options, 5
Yes.
millimeter and 8 millimeter.
5 and 8, and probably it used to be shorter.
It was used to be 5, so now we have 2 options.
Okay, so the 8 millimeter is to support higher power, I believe, was the conclusion.
It wasn't only to support higher power, but also to support if people would like to do vertical power delivery and to put components on the back.
Okay, so that 8 millimeter is coming from, that was the question actually.
Okay.
So to support vertical power and also for the 48 step down?
The 48 step down can be on the back or can be on the top. It depends on the designer.
Got it. And is that 8 millimeter totally available, or there is some clearance from that for if someone wants to build a vertical power module, for example?
I think the 5 and 8 mm is what we spec out in the spec, right? We work closely with the contribution from the connector vendor. In terms of the different height, right? You can consult and check with the vendor and see if they have a different type of a connector stacking height that available for you. Yeah. Mm-hmm.
Actually, I have one question. I think HIB, do you have any ongoing work on that front? Host interface board.
Yeah, I think this is a good question. I think back on the OAI 1.0, we're actually looking into the HIB implementation along with the UBB OAM. But I think what happened is that we got a lot of feedback, right? Right now, the system design, HIB is good for disaggregate the system, right? You have a separate head node. You want to interconnect the CPU to the OAI system, right? Then you need to have a HIB to have the PCI switches, etc. That you can do the on the other side. But there is another system implementation that also can be a aggregated design that you have everything inside the chassis. So in the 2.0, we do not define that because there is a lot more, I would say, flexibility in terms of the design. We do not want to spec out something that you have to fit everything, because it depends on the topology. PCIe, you can have a direct connect from the CPU or go through a switches, or you want to enable a scale up to the RDMA NIC, etc. That portion, right, if you want to define that, it's going to be very hard to do that. That's why we want to leave the flexibility there, right? The UBB spec on the I/O side, and then we want to leave the flexibility for the system implementation to do the design. Yeah.
Thank you.
I think no one will stop you to go to higher power. Yes, higher power is demanding, and people are looking for higher power, and no one will put a ceiling for higher power. So 1.2, 1.5, no one will stop that. You would like to add something?
So there are many things that we are looking into the high power, right? I think if you look at the advanced package technology, right, now everybody pushing a higher and higher, package getting bigger and bigger. And it depends on the package size, the power delivery solution, if it all fit into the OEM form factor, and also the power envelope of the chassis, etc. And also with the right cooling solution, right? It doesn't really prevent it to be beyond 1 kilowatt. If you look at the connector power allocation, right, on the connector side, we actually budgeting more than 1 kilowatt. I think 1.5 or so. It should be able to hit that, but still depends on the thermal boundary condition, right? Yeah. Mm-hmm.
All right. Thank you, Song. Thank you, Ahmed, for the sub-project update, and thank you for your work throughout the year.